Let's build a demo. And the first thing we need to do is to create a free SingleStore account. And we can do this from this URL, singlestore.com/cloud-trial/. And we can sign up using Google or Microsoft, or we can use first name, last name, and email address. And then once we've selected the option, we just need to click continue, and the wizard will walk us through the steps. And within about a minute or so, we should be able to access the new account. Once we've received the email confirmation from SingleStore, we can access our online account from portal.singlestore.com. Just enter that. And we can use our credentials, email address, and password. And we are logged in. So this is the new UI that's currently available. This is an option that can be changed, but we'll be using this user interface in the course of this demo. And if this is a new account, then we'll find that under deployments here on the left hand side, if we take a look, click this, we will see that there is compute provision for us, as well as a database. So this is automatically done for new accounts. So there's nothing that we need to set up here further. This will be perfectly fine for demo purposes. And we also have access to connectivity information here. So if we click on this, it gives us various options here, such as CLI client, for example, or SQL IDE, applications, or BI tools. So if we select CLI client, first time this is run, you get to choose your username and also set a password. And here we can see that we've got various items of information. So in this particular case, we have the username here. We have this long string for the host. We have the port number, and we have the database over here. And we also need the TLS SSL certificate, which can be downloaded from here. Okay, so this is required when we are building some external code, for example, a Python program that we want to connect to our database system using the free tier. So that will give us the information that we need, and we'll utilize this a little bit later on. For this particular demo, we're going to use some code on this repo here, which is github.com/veryfatboy/fintech-chatbot. And so we can use the option here to download the code. So that gives us the option to get the zip file, for example, or we could simply clone this repo as well. And if we took the opportunity to just spend a moment or two, we'll see that we have some details here which are related mostly to the Python code, and it tells us various software that we need to install, and there's a requirements file that we need to run as well for some additional packages. We have to set up our OpenAI API key as well, and inside the Python program we have some details that we need to fill in. So previously we were able to find these details: the user, the password, the host, the port, and the database. And with the free tier we also need the PEM file, which is here. And once we've got all the details, we're all set to go. And so we are going to use this particular Jupyter notebook here, okay, which is the FinTech Chatbot Full. There is another version of this here in this repo, which is a shorter version, but we'll use the longer version for this particular example. Back in the SingleStore portal, we'll select Data Studio from the left-hand navigation pane. And here we'll select Secrets first. And this gives us the opportunity to store keys, tokens, and so on. And as you can see, I've previously added the OpenAI API key, so I don't have to enter this every time for some new project that I'm working on. I can simply access it using a command, and we'll make use of that within the notebook we're going to use shortly. And talking of notebooks, we can select this button here, and one of the options that we have available is to import from file, which is what we'll use. And then all we need to do is to browse the file system and locate the file that we want to use here, which is the FinTech Chatbot. So let me do that, like so. And we can choose whether it's going to be a personal project or if we want to work on a shared project. So keep it in the personal location for now, and then just select the import notebook from here. And there we go, and we are all set to start working on this notebook. So we'll just check that we've got our compute resources and database correctly selected, and they are indeed here. So we can switch to other resources available, but currently I don't have anything else running here. So that's fine. And let's just scroll down then and execute these cells one by one. So we are going to look in this particular example at harnessing LLMs and speech recognition for personalized recommendation engines. And then just a disclaimer here that the stock data used in this notebook is entirely fictitious. It is purely for demo purposes. Please do not use this data for making any financial decisions. Okay, so this is rather important. And we need to install some libraries. So just clear the cache to begin with. And we'll get LangChain, LangChain Community, LangChain OpenAI, and OpenAI installed. This may take a few moments. Great, that's done, and we'll now import. There we are, that's done. And then here we'll create the database. Now, in the case of the free tier, that's unnecessary because it's already done for us. But if you are not using the free tier, then what this will do is it will create a database called FinTech Chatbot DB. And once that's done, if you are indeed using the standard tier, please check that it is selected at the top here, that the database is correctly selected, because subsequent steps will cause errors then. So we'll just do this. Okay, so there's no change, as you can see. I mean, it's using this database here that was automatically created for us as part of the process of signing up for the free tier. And then next we need to create this tick table, which is going to store the stock ticker information for us. So very straightforward. We have a symbol, timestamp, open, high, low, and closing price, as well as the volume of trade. And we are creating a key on the timestamp. So let's create the table. There we go. And next we'll create a pipeline. So this is a very useful feature of SingleStore. So we are connecting to a Kafka broker with this stock ticker topic, and the structure of the data. Here we have the various fields that we are picking out, and those match what we previously defined in the tick table. So let's create the pipeline, and this adjust offset is simply to say start at the earliest data that you have available. We don't need to use this, but it can be useful, so we'll do this. And then before starting the pipeline, we can test it, make sure we are receiving some data. And in this particular case, I've opted to just limit it to one row. And if we run this, we get back some sample data here. So as we can see, we have the symbol, timestamp, open, high, low, price, and volume. So data appear to be coming through correctly. And then all we need to do then is just to start that pipeline. And to stop it, obviously the command would be stop pipeline tick. Okay, so in this case, let's run this. Just wait a moment or two, and then what we can do is this select count star from tick to find out if any data have arrived into the tick table. It may take a few moments to feed through. So whilst I've been talking there for the last moment or two, perhaps some data have arrived, and let's try and see if we've got some data. And indeed we have. So it tells us here we've got 9 million records already. So that's good that there's some data to work with. And so one of the things that we can do is just do a little bit of analysis of the data, and a very useful feature in time series data, for example, and working with tick data is do these kind of candlestick charts. And we can do that directly using SQL, creating this time bucket as it is. Let's take a look at that. And this is for the symbol AAPL, Apple. So it has found 2 rows so far. So we can see the date here is the 12th of September and the 13th of September. Okay, now remember, this is all fictitious data. So this is being generated for us. This is not real data we're working with, but that's fine. I mean, it's representative. It's good enough. And here it's just reminding us to make sure that we are correctly connected above, because we are going to use SQL Alchemy just below here. And let's run that. And then we can do the same here using Python. So create a visual candlestick chart. This is using Plotly Go. So let's execute this. So it prompts us for how many days. I just take the default there, 3, and take the default symbol there as well, which is Apple. And it's created this for us. Now, there's not much data it's working with at the moment, so that doesn't look very interesting. But if we leave the pipeline running for a while, perhaps when we rerun this, we'll see some more interesting sort of pattern and behavior. All right, let's now go down a little bit further here to the LangChain SQL agent. And so here, first thing we do is to get our OpenAI API key using secrets, which we looked at earlier. And we also set the large language model, which is going to be this GPT-4o mini. So let's run this. And here we provide some details about the database, the URL, and also constrain it just to look at the tick table. Now, initially that's all we have, but in an environment, for example, if we had lots of other tables, we don't want LangChain and subsequently the LLM going off and looking at all those other tables. So we make sure that it says that this is the only table that we currently want it to look at. We use the SQL Database Toolkit here, point to the database and the LLM, and then we subsequently create this agent. And let's do that. There we are. And then we've got a couple of examples of queries just below here. Now, here's a little bit of error handling. So one of the issues that I found recently was that some output being returned from the LLM to LangChain was not being processed correctly. I think some issue with the parser. So the output actually looks absolutely correct. So all this does is just handle that situation for us so that it can be processed correctly. So let's just execute this. And then here we've got an example. This query is asking for each stock symbol, calculate the volatility as the difference between the highest recorded price and the lowest recorded price over time. And then we're asking which stock symbol has the least volatility. So let's run this and see what response we get back. So it tells us that the answer is FTR. And so just below there, let's run a SQL query that achieves the same goal as the question we're asking there. And according to this, it is indeed FTR with a volatility of 0.55. And then let's try a second query here. So in this particular case, this gives us a bit more flexibility because it's not hard-coded, although there is a default there. And so let's just take the default on this occasion. Okay, so it's prompting us, and then I'll just hit return to take the default, which is how many rows are in the tick table. So the result we get back is 9,272,498 rows are currently in the tick table. So as you can see, previously when we queried the database, it was less than that. So in the meantime, our feed has resulted in more data being stored in the tick table. And what we can do is we can do the same using SQL. So I select count star from tick, and there we can see that the number returned is indeed the same as the natural language query just above. Okay, and now let's take a look at the Python code. So at this point in time, we'll switch to the Python code that's part of the GitHub repo, and let's run that and see what sort of responses we get back from that. In this environment, I have installed all the required software and packages. I've also updated the Python program to contain the username, password, host, and so on, okay, as per the GitHub repo. And I also have an export for the OpenAI API key so that the Python program can pick that up from the environment. And so let's just run this. And let's just minimize this and move this into the center here, like so. And let's ask some questions then. So I'll start recording. How many unique stock symbols are in the tick table?
There are 491 unique stock symbols in the tick table.
What is the highest price ever recorded in the tick table, and for which stock symbol?
The highest price ever recorded is $1,535.81 for the stock symbol PCLN.
Which stock symbol had the highest trading volume today?
I don't know.
What is the average closing price of all stocks in the last 1 hour?
I don't know.
For the stock symbol AAPL, how many price ticks were recorded in the last 24 hours?
There were 0 price ticks recorded for the stock symbol Apple in the last 24 hours.
Which stock symbol had the most price fluctuations in the last week?
The stock symbols with the most price fluctuations in the last week are PCLN 7.69, ARZO 7.27, and HCN 6.60.
What was the highest price of AAPL in the last week, and when did it occur?
The highest price of Apple in the last week was 119.43, occurring on September 13, 2024, at 17:32:32.
Which stock symbol had the lowest closing price in the past 48 hours?
I don't know.
What is the best investment strategy?
I don't know.
Using the tick table and looking at volume and price, what is the best investment strategy?
The best investment strategy based on the tick table is to consider investing in FTR, which has a high volume of 6,698,028 and a price of 3.73.
Who was the first man on the moon?
I don't know.
Okay, so that last query was really to test to what extent it's looking at the schema and the database and the data that it can see versus a general question that you would ask a large language model. So previously when I've done this, it actually came back with Neil Armstrong. Now it's much more constrained and seems to focus specifically on what it can see in terms of the data in the database, which is good. So that's a good development. So a mixture of examples there. Now obviously it's good to check these and verify the results that are coming back, and sometimes just rephrasing a question can lead to a result. So you saw that I asked about the best investment strategy and it said I don't know. However, if I qualified that a little bit and then provided with a bit more context, I said, look at the volume, look at the price, what do you think? And it came back and suggested something in that particular case. So now we are back in the SingleStore portal and looking at our notebook again. And there is a bonus section to complete if you wish to do so here, where we are actually going several steps further. So we are creating a portfolio table, and a stock sentiment table, and just inserting some values here into the portfolio table. Again, please note that these are made up numbers in terms of the purchase price. And then we are just running some queries here just to check that the data have been correctly stored and get an overall assessment of the value of the portfolio. For the stock sentiment table, this is quite large, and there is a link here to the location of that data on GitHub. So it's a zip file. You just need to download it, unpack it, and then load it into the database here. So you've got some instructions here using the CLI. Okay, a couple of formats there, whether you want to do it line by line here, for example, or put everything on one line. And then just below is a fake example with a fake user called John Doe, fake password, and a host, the port number, the database name, and then the using the stock sentiment.sql file. So again, two examples there if you want to do it online or if you want to put everything on one line. And that takes a few moments to load. It is quite a large database, but very useful to have. And again, running a query here, and you can get the headline, the positive sentiment, the negative sentiments, the neutral sentiment. And this data is actually from Kaggle. So that is actually, I believe, based on real data, whereas the ticker data we are using in this example is fake. I believe the data here for the stock sentiment is actually drawn from real data. And then again, we set up the LangChain SQL agent here, and this time we not only include the tick table, but we include the portfolio and the stock sentiment tables as well to give it more data to look at. And again, if we decide that we don't want to do that, we can constrain it to just whichever part of the database we want it to look at. And once we've set that up, we've got some example queries here. For example, the third query, taking all the stock symbols from the portfolio table and using the latest value for each stock symbol from the tick table, calculate the grand total value of all the shares listed in the portfolio. So that's quite a substantial query to run. And in SingleStore, for example, we would use the common table expression, CTE, to actually accomplish that. So here you can see the SQL code to do that, fairly complex. And then for the fourth query, we're using the stock sentiment, using the symbol AAPL, show me the date and the most positive sentiment in the stock sentiment table, and the current best price for this symbol from the tick table. So again, you can see there's one solution there in terms of how we could do this using SQL. Now, one very useful feature to know is that if we would like to see LangChains working out, how does it actually arrive at the answer, in terms of how the agent is working, there is this verbose mode. So far, this has been set to false. But if you set this to true, it will actually show you it's working out, okay, the process that it's gone through to arrive at the answer. And that's very useful because then you can compare that to the SQL query that will give you the correct answer and see whether it's been able to understand the natural language correctly. Finally, it's a good idea to do cleanup. So we would stop the pipeline, and if necessary, drop the pipeline. And here you can see I've also dropped the tick and portfolio tables, but kept the sentiment table because it does require some effort to load. And therefore, the tick and portfolio tables can be easily recreated whereas the stock sentiment takes a bit longer.